Our current electric grid was conceived more than 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener. The smart grid enables newer technologies to be integrated, such as wind and solar energy production and plug-in electric vehicle charging. With our participation as informed consumers, the smart grid will replace the aging infrastructure of today's grid, and utilities can better communicate with us to help manage our electricity needs. The smart home communicates with the grid and enables consumers to manage their electricity usage. By measuring a home's electricity consumption more frequently through a smart meter, utilities can provide their customer with much better information to manage their electricity bills. Inside the smart home, a home area network, or HAN, connects smart appliances, thermostats, and other electric devices to an energy management system. Smart appliances and devices will adjust their run schedule to reduce electricity demand on the grid at critical times and lower consumers' energy bills. These smart devices can be controlled and scheduled over the web or even a TV. Renewable resources, such as wind and solar, are a sustainable and growing source for electric power. However, renewable power sources are variable by nature and add complexity to normal grid operations. The smart grid provides the data and automation needed to enable solar panels and wind farms to put energy onto the grid and optimize its use. To keep up with constantly changing energy demands, utilities must turn power plants on and off depending on the amount of power needed at certain times of the day. The cost to deliver power depends on the time of day it is used. Electricity is more costly to deliver at peak times because additional, often less efficient power plants must be run to meet the higher demand. The smart grid will enable utilities to manage and moderate electricity usage with the cooperation of their customers, especially during peak demand times. As a result, utilities will be able to reduce their operating costs. By deferring electricity usage away from peak hours and having appliances and devices run at other times, electricity production is more evenly distributed throughout the day. The power being used right now was generated less than a second ago many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity production, reducing the need to fire up costly secondary power plants. The distribution system routes power from the utility to residential and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any break in this system caused by storms, bad weather, or sudden changes in electricity demand can lead to outages. The smart grid's distribution intelligence counters these energy fluctuations and outages by automatically identifying problems, then rerouting and restoring power delivery. Utilities can further use distribution intelligence to predict and manage electricity usage with the cooperation of their customers, leading to lower production cost. The charging of a plug-in electric vehicle can be managed over a home area network, or HAN. The HAN can balance the demand for electricity across the household and prioritize between the electric vehicle and other appliances to manage electricity usage and reduce costs. With smart grid technologies and consumer participation, utilities can more easily handle the increased demand for power to run the electric vehicles and ensure charging needs are met. By adding more plug-in electric vehicles to the grid, we have the potential to reduce fuel costs, lower our dependency on foreign oil, and help reduce greenhouse gas emissions.